It's Friday. We're almost there. So I feel like I've been talking about this topic for years now, but finally starting to make a little bit of progress. And the hard part of bringing together open source communities to solve problems together is that it takes a lot of time. And part of that is like just the inherently anarchical kind of anarchy nature of open source software that makes it so great that everyone is kind of working in a distributed fashion, solving their own problems. And every now and then you come together and say, hey, let me tell you about my problem. And maybe there's some overlap in our problems enough such that we can build a piece of software that we can share. So just a brief couple of words. One of the things that's happened in the R and Python community in the last few years is an organization called NumFocus got started, which enables corporations to donate money to support and fund open source projects for doing data science and data analysis, among other things. And so if you're a business and you've ever wondered, how can I take money and give it to the people working on these open source projects that we depend on, NumFocus is a really great organization to do that in a way that you can also, I think, maybe get a tax write-off. I don't know if that's exactly true. Talk to your accountants and figure it out. So recently, Pandas received its first major donation of $25,000 to support development, and hopefully we'll see more of that in the future. I've also gotten involved in the Apache Software Foundation since being at Cloudera the last 18 months, and similar mission of establishing procedures and helping the open source community organize themselves for the benefit of the world, hopefully at the end. So I work on data science tools at Cloudera. I've been there for about 18 months. I was a startup founder before that and lived and worked in New York, the New York area for a long time. But now, actually 2 days ago, on April 6th, 2008, I started working on the project which would become Pandas. And it's funny to reflect on nearly a decade of your life, and the day-to-day work, the things that I'm working on haven't really changed all of that much. And so there's a certain Groundhog Day-like aspect to it, but I'm okay with that as long as, and I do ask myself on a weekly or monthly basis, like, am I still moving the needle? Am I still making things better for open source software? And I still feel like I am, but it is important to reality check to make sure you aren't chasing your own tail over a long period of time. Mostly do Python, though increasingly doing more and more C and C++ development. I also signed on to update my book, finally, which will be 4 years old in October. And as far as open source software books aging, most of the code still works. And we did go through a major revision where we fixed all the broken code, because some of the code obviously did break, as with any fast-changing open source project. So Pandas is 8 years old, and so this book was published 4 years ago. And so a lot has happened since then, and it will be due for an update, and also to incorporate some of the great stuff that's been happening in the rest of the Python data ecosystem. So my ulterior motive in giving this talk is to sell you a bit on a new community initiative that we started within the Apache Software Foundation called Apache Arrow. And it's a little bit esoteric compared with many of the kinds of software that you hear about here or that you hear about at the typical Python conference. And I'll explain why that is. And so as I started to look around at all of these Apache kind of open source big data projects, everything related to Hadoop and Spark, ways to take code, move code to data, and scale computation, I found that these projects were fairly unfriendly to Python and R in particular, and started looking at some of those low-level issues of like, how do we connect these systems together in a way that is easier for me as a programmer so that I can build connections to systems and have a straightforward way of using Python or using R in these environments. And so the big issue there is data. You can think about data frames in R or data frames in Python. you can think about those data structures, like what's inside an R data frame, what's inside a pandas data frame, as being this proprietary thing that other systems can't really understand. And so the nutshell summary of Arrow is that it's an effort to create a data frame-like structure that can be used in many different projects. And so if two systems say, we use Arrow or we expose an Arrow interface, that's a straightforward way where you can say, give me a table or here's a table. And there's some other details there where you can say, like, here's what the table I'm about to send you is going to look like. Here's what the column types are. Here's what the column names are. It does some other things to support the needs of more complex data that's increasingly showing up, things like JSON, nested data, which you don't see as much in Python and R. But we really spent a lot of time engaging with, particularly like the Apache ecosystem, where really big systems that are very complex. It takes a long time for them to make internal architectural changes. And so we wanted to spend a lot of time getting folks on board to make sure that the project could meet the needs of many different open source projects. And so it's not really tied to any particular programming language. Ultimately, you have a set of specification documents that describes what it means to implement Apache Arrow. So this is like the most succinct way, and the VP in Apache speak of the project is a fellow named Jacques Nadeau, who was one of the people that started the Apache Drill SQL engine. He made these diagrams and kind of explained the conundrum that every time you come to the table and you say, well, I want to talk to this system and that system and that system, and you end up having to build a converter to talk to each of those systems in pairwise fashion. And so you end up with this like combinatorial n choose 2 problem, where as soon as a new thing comes to the table, you've got to figure out how to talk to that. How do you send data back and forth? How do you message with it? And so what the project does for the developers of these systems is it gives us a common way to move data around, kind of turns data into a commodity that is less fragmented and more interoperable. So it kind of makes data more like crude oil or natural gas or something that can be moved around very, very cheaply. And in practice, if you look at systems where data is moved between them, so whether it's sent directly in some kind of binary stream or it's written out to say a CSV file, you find that in a lot of data analysis, the analytics itself is fairly simple, and a lot of CPU cycles are being wasted converting between different data representations. And so that can be, could be small amount of CPU cycles depending on what you're doing, or it could be, I've seen, 95, 97% of processes be all just converting and moving data around, which is sort of too bad. So just to see what we could do with this project that would be useful to the Python and R community, is I saw Hadley at the end of January, and he mentioned that that readr file, that he could parse CSV files with readr faster than he could load .rds files in some cases. And that seemed a little unfortunate because RDS is this binary file format. And so we started discussing data frame memory representations, how things get stored on disk, and whether some of the stuff that we were doing with Arrow could be relevant for the R community. So we decided to create a data frame file format that was the simplest file format that we could create, that would be able to store data frames from both Python and R in a language agnostic way. And so if this thing works, I installed RStudio this morning on my Ubuntu laptop, so here it is. And so I have a data frame that I generated, which is 10 million rows. It's all numbers just to keep things simple. 10 million rows and 12 columns. And so doubles are 8 bytes, and so that's 960 million bytes. So just shy of a gigabyte. And so what the Feather package gives you in R, you load Feather, and it's about as simple as, let me try actually, write Feather, is you call write Feather with df, and then you say some file path, and then it writes the data frame to disk. And then, so we can call the function Feather metadata on test.feather, And it tells us that we have a feather file. It's 10 million by 12. And here's the column names and their types. You can all see that. Hopefully, I should have made the font bigger. Now I'm going to go to my handy-dandy R terminal. There's test.feather on disk, just shy of a gigabyte. Load IPython, import feather, read data frame, test.feather, and df, and df head. So there's the data frame in Python. And the nice thing is this was like a gigabyte of data, and I'm sort of cheating because I have non-volatile, I have like a PCI Express hard drive in my computer, so it's really, 500 milliseconds to load a gig of data is hardly playing fair. But I can write, what's nice is that I can write that data back to test2.feather, and then back in R, read feather, test2.feather, and let's call this df2. Okay, and now it's back in R. And so that's nice. But I think the best part of the project, there's not a lot of code, which is a feature and not a bug, is that it's extremely simple. And the way what we did is we created a C++ library, and maybe we should have done it in C, but we had some reasons for using C++. And so we used the same core library to implement the file format. So we just put the data without modifying it all. It uses the Apache Arrow memory layout. We have some metadata, and we're using this project called flat buffers to store the metadata. And then Hadley wrote an RCPP wrapper. I wrote a Cython wrapper, which dealt with converting between the in-memory R data frame and the in-memory pandas data frame to the feather format. So this is cool, and I like the project as a model for how the Python and R and also the Julia community can collaborate, because we can all call C libraries, and we all know about data frames and tables. And the problem is that our data frames in memory are different. So there's good and bad things about Feather. So the best part about it is that we have a language-independent way of storing data frames on disk. It's extremely fast. So in the case of numeric data, reading and writing is basically as fast as your hard drive is. And there's probably some tricks we can play in some cases to get better performance with compression. But we didn't do any compression or encoding. We ran the benchmarks. We were like, OK, it's fast enough. We don't need to do anything more. So the speed and the fact that the files are the same in both Python and R is really nice. And we can add new data types and then figure out if there's some data type that R doesn't understand under the hood, we can convert it to something that can be worked with in R, whether it might just be converting it to a character or a factor. The downside of Feather format, and something to think about in the years to come, is the fact that the way that the data is stored and represented in Arrow data structures is different from R's data frames and different from Pandas' data frames. And so if you think about Google Slides. So if you think about things like the in-memory backend for dplyr, so almost everyone who uses dplyr uses the C++ library that Remind Francois and Hadley built to do all of the transformations. So every time you see a new verb in dplyr, there's an equivalent routine in C++, which takes input data frames, applies the operator, maybe in a group by context, and then creates a new data frame. And so all of that code is written assuming the byte level, bit level memory representation that R uses internally. And Pandas similarly has, all this code that involves, doing group bys and all of the same stuff that dplyr does. And dplyr's code is, in a lot of places, frankly, quite better and has a lot more. There's my kind of scattershot, implement a bunch of database stuff in Pandas, and if I'd go back, I'd rewrite half of it. But it works well enough, and so, if it ain't broke, don't fix it, right? But it would be really, really nice if we could figure out a way to share more and more actual algorithms and stuff like the dplyr, the pandas stuff, it uses a common data frame representation that can be shared across our toolkits. And that would offer a point of collaboration for all the communities to build algorithms and data transformations, all the string munging, all the work that we do in data preparation and feature engineering for machine learning. And kind of at the end of the day, we're just trying to make a visualization or build a model. And so it would be nice if we could share more of that code. There's other problems that have to be solved, stuff like boring stuff like licensing, and we have to figure out how to ship the code once we build it. And we had to figure that out for Feather. It was like, well, just shipping a small C++ library is a hard enough problem, it turns out. But some things we can all think about as a community and work on. And if there's obvious points of collaboration, ways we can share code, just thinking about how you would deal with an Apache Arrow-based data frame in memory, both in Python and R. You're almost having to build a whole new ecosystem of tools. So maybe it's not feasible, but I can always hope that in 5-10 years from now, the world will be different. So it's a neat project, and if you're interested in interoperable data frames and code sharing amongst data science languages, this is a great way, and it's a small project that you can fit in your head. There's not a lot of legacy systems or code to master. The specification for the data frames, the Arrow kind of arrays, tables, very, very simple. It's mostly about the schemas and the way that two systems can say, here's what my data looks like, tell me what your data looks like, and we're going to send the data back and forth. And we did something, if you look at the details of the Feather file format, we actually implemented our own slightly customized metadata for storing the schemas and the types and the column names and all that. But as the project develops, that will become increasingly standardized, and will suit the needs of more and more systems. It was a fun project, and if you'd like to learn how to create data frames in C or C++, the R part of the I've been actually making changes, even though I don't know how to compile RCPP on my laptop. I've been, I broke some things in the C++ library, and I fixed the RCPP bindings, and then the Travis CI build passed, and I was like, well, I don't know how to build it, but I was able to fix the bindings. So it was nice that I didn't have to go bug our people to fix stuff that I broke. So if we could do more of that, it'd be great. But I have a few minutes for questions, but it's kind of a big topic, but just wanted to give you a flavor of what the future might look like and some of the architectural technology approaches that could enable us to share more code and build kind of more interoperable data tools for the future. Thank you, and I've got 2 minutes for questions, so I could also give my time to the floor. So I will say about Feather, don't jump to replace all of the data that you're storing on disk with it right away. And maybe at some point we'll say this is blessed for medium-term data storage on the horizon of 2 to 5 years. But at least for the moment, the file format internally will change. So files that you're writing today, you may not be able to read with the Feather trunk a month from now. So caveat emptor. All right.
Any questions for me? We have time for one. Pick the best one, Wes.
We got one right here.
Yeah, you showed an example in R and in Python. Have you created the format for these other tools that you mentioned at this point?
So so every system is a little different as far as what sort of port should we build to push and pull data. So for example, we've been talking with the Spark community about offering being able to write operators in a Spark context in either Python or R. And so if Spark could hand off data frames, and you could write dplyr operations or pandas operations on chunks of data coming out of a system, like a generalized distributed data system like Spark, that would be really cool. But that's slightly different from this just handing off data frames to and from Python. So I think implementing operators in languages like R and Python is one area where we'll be doing a lot of work. Yeah. Thanks, Jared.
Thank you, Wes. That's fantastic.